Alright, welcome back generals to another Let's Fix the Generals 0 to make the best game ever. We are still developing an unassemblize tool to aid the Thyme development efforts. Okay, so we have, what did we implement? Alright, last session we broke some things apart here. We need to get an overview. What did we want to do? Update selected functions. We should probably have this. 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 Yeah. We do selected. If assert it's kind of weird. Dot size version name functions dot size. Move this. Std move that and that and that. If that index, hold on, we can simplify this. We can remove this one here. If that dot is matched, else. So we got this dot pushback index and selected matched functions pushback index. Okay, I think that will do. Okay, next. Update selected matched functions. Matched. Let's rename this to matched named functions. Um, mm, hmm. So here we do selected matched named function. Select matched named function. There's a bit of a name ambiguity now with matched named function indices, and here matched functions. Matched functions. Oh, I see. So this should be actually called matched functions. Okay. So selected matched named function indices, and the same here. Can do assert. Don't need that. I think we can remove this stuff here. Oh no, we can't. How about we put this here and this here? Then we delete these guys. Then here we put assert is matched. Let's remove. Shrink to fit, yeah. Shrink to fit. There we go. Okay, I think this is correct then. Maybe we can simplify this code to simply say files 0 and files 1. Then we remove the loop. Done. No need to loop them. Okay, so analyzed matched functions async. Yeah. Okay, so here we can now put unmatched named function indices. Process remaining named functions. These are unmatched functions that were not already processed above. I wonder if we should also pass here the named function indices to this one. Process matched functions. Matched functions. Actually, what we can do is we can now I actually wonder if it really made sense to split these in two. Maybe we didn't need to. Maybe maybe it was fine. Actually, I think we don't need this guy here. Because we probably want to build it Maybe we should have selected all named function indices. For our purposes, I think we don't need this guy. We only need the unmatched ones. But for simplicity, maybe it should be all named function indices. Essentially, I think for our matched functions here, for this, we need a different strategy to build these. We build these from the matched function pair because it has both sides that need building. Okay, how about we comment this out again, put this guy back here. Yeah, okay, let's see what fails compiling now. Well, everything again. Then let's put this back and comment this out again. Then let's comment all this. Selected all named functions. Reserve. There we go. There we go. Ta-da. Da. Don't shrink. Selected all named functions. If is matched. Okay. Indices. Oops. Okay, let's try that. Selected all named functions. Okay. So basically, I think what we do is in this function, we build new vectors for both sides. Yeah. Let's see. So, matched named function indices. So, Do we have like some function that can do that already? Matched functions, let's say. No, it's just a vector. Okay, how about we add a new function here? Build std vector. Of course, it deleted our stuff. Vector index t. Build named function indices, and it takes matched function const. Hold on, matched functions. Matched functions. Maybe we give it a span. Span. Span const matched function. Matched functions. And then index side. Then we do for const matched function and then std vector index t indices. It's the named function indices, and we resize it. Count matched functions dot size name functions let's do const size t count equals that const size t I equals 0 I equals smaller count plus plus I dot no I equals matched functions I dot named index pair side dot, that's it. What does it return? index. Okay. So just like that. And then return this. Okay. Then we take this guy, go to imguif, named function indices array, span. So I think we need to create an std array of std vector of index t to named function indices array, and then we do name function indices array, and then it's a build named function indices so this is all matched named function indices, matched build name function indices, and we pass this comparison descriptor matched functions and the side I. Okay. So that is step one. And then we need to put this here. We call this analyze named function indices array. I put this guy here, and this one is span there we go. I think this is correct. Well, yeah, I think it's correct because our persistent indices will be stored in here. So this span here will now point to what's in here. And this one is just temporary, so we can safely delete it once it goes out of scope. Actually, we can put this here in the scope like this. Yeah. Actually, we can probably put this here into the same loop. Match functions I. Comparison descriptor of files, revision process named functions, get items for processing, span. Yeah. Yeah. Nice. Okay, and with this information, with this array here of the spans, we should now be able to do this stuff here. So analyze. Should I? Well, we can probably put that in here. And then we just keep on going in here. Right. Um, we probably want to create a function that does all these three things chained together, I think. How do we call that then? So it would be maybe we call it creates. Process selected functions commands, maybe. Not sure if that naming makes sense. And then basically we will take these guys here and how do we combine these guys? Maybe we say auto. So typically we always we return a command like this. Maybe we do commands and then we do chain to last. we say delayed commands. What does it return, this one? Delayed commands. Delayed commands. Delayed commands. Oh. Chain to last. And then another delayed. Or we simplify it to just chain to last. Yeah. Yeah, I guess we can do that. Oh, I just realized did some mistake here. This one should be that one. Process selected functions command. Okay. And then we take this guy and we put it here. Auto commands this. We give it this. Okay. And Q commands. There we go. STD move commands. There we go. Okay, and then here we do. We also create a command here, but we chain something additionally. Revision descriptor. Let's put a revision descriptor. Const revision descriptor revision descriptor. Put that guy here and there. Well, do we really need those arrays here? I do wonder. It looks like we actually don't need them if we pass the spans right away. We don't need that here. Then we just put here. We put this here, named this. Matched named function indices. Make it a const, and then const span. Analyze named function indices. That. And then we pass this here. Oops. And then we have a command, yeah. And analyze matched function is. actually. Hmm. We only need to post async commands if there's actually something inside, if they are not empty, right? Okay, in that case, actually, we should go back to our arrays. Then we should put this here. And then we say if this if 0 dot empty, not empty, or that not empty. But then the question is, how do we know if both have finished, if just one has started? Well, if one has finished, if just one has started. Well, if two have finished, if two started. Okay, that's a problem. So essentially we would have a for loop in here, and then we put this guy here, and then we have this guy in here. Wait, revision descriptor. Put this here, and then we put this guy here. So then here we would have command chain to last, where we would say similar to how we did it here, chain to last. Then we would have to do something at the end. But what do we do there? I don't know yet. Yeah, and basically we queue this guy. Work queue and queue std move commands. Yeah. Otherwise, if that was not the case, then we would go straight to the next step. To do next step, which is basically calling into some function where we pass this on again. Yeah, basically we would have a here analyze matched functions. We would create a copy of this guy and async, and we would have a second version of it. Maybe we call it analyze matched functions. Analyze. Let's call this analyze named and matched functions. then we have this, analyze matched functions. And then analyze matched functions. We would then call in here where we would pass on our comparison descriptor and also this here. And then here we would also call this. And then here we would continue then. Let's say here process named functions first. Named functions have been processed are already okay. Proceed with the matched functions. I think this thing here, this one we can also take out here actually. Like this. Collect named function indices to process, if any. Okay, this makes sense. Well, we could put this here into a standalone function, and this as well. Yeah, we could break this up into smaller functions. Yeah. Yeah, so can we maybe put this here into a standalone function? Maybe it would be in a comparison descriptor, no? Yeah. Let me see. In the comparison descriptor, we would put my gosh. Collect name function indices. So we need a function that, how do we call this? Gets functions for processing. Get named functions for processing. Yeah. Yeah. Let's see. Here, we do span const index t. Oh shit. Oh. Get get named function indices for processing, right? And this function is not const, yeah. So put this here. And we take this guy and put it in here, and that will be get named function indices for processing. We need to have index t side, or let's say file index. Let's go with side for now. So it will be this. So side revision descriptor. Maybe we just do here, put it directly side, and this will be return this. Side. Then we remove this. We can make this also const. And that's it. Okay, it's greatly simplified. Okay, let me go back in here, wherever that was, here. And then we do we do 0. Comparison descriptor. Get name function indices for processing. And 0. 1, 1. Okay, I think that is greatly simplified. Now the question is, do we want to simplify anything here? Oh, I'm not sure. No, I think it stays in here because it does have async command, which you put here, so that's fine. Chain to last. Yeah. Okay. Now, but now we need a condition here that to only call this function here when both are done. Both have been processed. How do we do that? Oof. Oof. We can't really see when the other is done. That's a problem. By the way, no, that's correct. Yeah, that's correct. Already processed. Ideally, with some elegant solution, we can figure out that the other side has already been processed. The problem is we don't get any state back, but instead we just process on like established list of functions. Ugh. Ugh. Oh boy. Well, we could always check like, are all these functions processed and ready? That's not good. Can we maybe give a state with this callback to say we can Oh, there's also something else I just realized. Where's this function? Create, builds, process selected functions command. This one. This one should only be done if you have a PDB loaded. And this one as well. So here we say if revision descriptor PDB loaded only then we chain these. But by the way, we also need to return command here. I wonder if we should chain here chain another command that simply sets a state inside the revision descriptor that all the processing is done. Just saves the state. Yeah, maybe. Actually, revision descriptor. So it does have a function already to check if named functions are built. Yeah, how about we add another boolean here for named functions disassembled, and then another for so we could have bool named functions disassembled false. Then we could have another named functions we could have a tree state again. Make a tree state. Tree state named functions so basically we have here source lines for selected functions built. So source lines for named functions. But that doesn't make sense because we are only disassembling parts of it, right? We're not doing the whole thing. Yeah, that won't work. That won't work. No, we can't do that. Okay, we need some strategy, but I don't see it right now. But it is lurking somewhere. It is there. There is a strategy, but I don't see it right now. I mean, when this is done, we could chain a command here. Well, we don't need to chain it here, really, but we need to. We need to somehow here at the end of this, we need to know whether the other one has already been completed. How do we know this? There must be a clever way. Let me see. We can. Well, we. Ah, no. Well. So one way would be to allocate some object, some state object, that we give to both these callbacks, and if this state object signals that both are done, then wait, there's also something else missing here. If not empty. I think we should rename this to get matched named function indices for processing. Oh boy. I mean, yeah, we could allocate some objects, a shared object. Yeah. I mean, it's not great, but I don't have another idea here. Yeah. Okay, so let's draft this here. So basically, we would first say we would have a int analyze named functions count is 0, and then we do if not this empty, plus plus, and then if not this empty, plus plus. Okay, then we say if this is larger than 0, and then we put a std auto shared state std make shared, and we just allocate an integer, and we just give it this count, and then we pass this shared state here, and then in here we do shared state we decrement the shared state, and if shared state is then 0, then we call this function here. I think this would work. Yeah. Yeah, I can't think of any other way in this case, because we can't save anything in our in the revision descriptor, because we only process part of this thing, right? So I think we can only do it this way. So there's like one allocation here, but yeah, okay. Then I guess it's fine. Yeah. Maybe we can give it a better name. Shared work counter, work counts. And if work count is 0, then we go to the next step. Yeah. and it's initialized with this count. Can we make this a bit nicer? It's a bit hard to read, isn't it? Well, we could do this. Maybe that's easier. Maybe. It's a bit rough on the eyes. Yeah. Well, I guess it works for now. Okay, I think this flow would work. Maybe. Yeah, let's see if it compiles. Yeah, it does. Okay. Okay, and then when this is done, then we would also here in this function, what do we do next? So comparison matched function indices. I think there we simply create, what is it? Ugh. Here, this one, isn't it? Build comparison records for selected functions command. That's a mouthful. And we pass this guy and this guy. And then we enqueue this. I think this is all, right? Yeah. I think so. Okay, so this could be... This could already be functional. Oof. Let's see. Let's put a breakpoint in... What is going on here? Named and matched functions. Ah, okay. Do we actually call this already? No, we don't. We need to go to on function interaction. And so this one needs to be called here on name, analyze named and matched functions async. I wonder if we should rename this to process named functions async. Instead of analyze. I don't know if analyze is a good word here. Maybe call it process. Okay, that didn't work. Process. Okay. create process selected functions commands. Okay, this may work, but we still have a problem, at least one problem. I don't know if it, well, it won't manifest to an issue right now, but we need to, yeah, I already added to do, so let's check. With the file content storage, we looked at this in the last video. That needs a solution. Oh, okay, but I think we can already test what we have right now and see if it works in principle. Right. Okay, where do we put a breakpoint? I think here. Yeah, let's see. This is quite intricate logic, so hopefully we made no mistake. It's easy to make mistakes here, I would say. Okay, let's see. So we compare this junk and this one should size 0. Okay, what if size is 0? Then what happens? Then okay, somehow this is 91. Okay. Okay, that is unexpected, isn't it? We didn't select anything yet. How did that happen? Get items for processing. Oh. Right. Right. We need to use this one here, selected matched function indices. This one. Which also means we don't need this here. Right? So let's comment this out. I think this means we don't need this function here, which we have so proudly implemented before. Can remove that again. Oops. Okay, let's try this again. Compare. All right. So, matched function indices, 0, 0, and well, I mean, if this is 0, well, let's keep on going for now. So this should now also equate to 0, and it is 0. So there's nothing going on here. 0, 0, and then it goes in here, and it still creates a command. Yeah, with 0. Okay, so we need to prevent calling. Let's hold on. Ugh. Where are we? Hold on, that is wrong, isn't it? Matched function indices. No, it's correct. It's not. No. Links to matched functions. Oh, hold on. This is incorrect here. Oh, this is not correct here. Um, oof. Um, mm, mm, mhm. Yeah, this is not correct because these indices are not for named functions. Um, oof. Um, I think we need to have a function where we pass this, but also indices. Yeah. Uh-huh. Yeah, then... Hmm. So let's go to... here. Build name function indices. So we would pass this and matched functions, and then we would pass a span const index t matched function indices. So then we would do this here, size, count, and then this equals matched functions, named function indices, I, name pair outside. Okay. I think it needs to be like this. Oof. Yeah. Then here we put this. And then this. Poor. I wonder if this is the right place for this function here. Maybe we should put this function into the comparison descriptor. Because we don't use it anywhere else. MGUI app, yeah. So we have static. We put it here at the end. Where's my file here? Put this here. Okay. Maybe we make this a private function. Okay. Okay, I think this is correct now. Unless, of course, we made an error again, which is always possible. Okay, let's see. Compare. Okay, before we continue here, how about we now do if matched function indices empty. If not empty, then we do this. Oops. And the same here. If not empty, then that's all right. Okay. And maybe we should also put an assert in here. Assert that we don't expect this to be empty, because it's useless to call this with empty, right? Okay, let's try this again. Compare. All right. Good. So function indices is 0. So we do nothing. And this one is also 0. We do nothing. Okay, great. And this is for the other one. Okay, great. Okay, so let's go to a single bundle, which should also now do nothing. Yeah. And now we select here one. we select here one function which should essentially match function indices 0. Yeah, but it probably gets one here. Yeah, size 1. Let's see what this does now. Okay, it creates the command. The command has a chain, right? Yeah. Next delayed commands. Next delayed empty. Okay. And then we enqueue this and let's see what happens. Yeah, we did not see. Maybe we should put some breakpoint here. Hold on. Let's put a breakpoint in. Creates process. Yeah. We can put a breakpoint here and here. Oh, that's kind of awkward. We can't put a breakpoint in here because... Oh, that sucks. Yeah. There's once again, the Clang formatter screws us. We can't put a breakpoint here because this is not on its own line. That's some bullshit. Okay, but at least we can put it here. Okay, so basically this should now call when we select the function, right? Let's see. Yeah, and that was relatively fast as well. Okay, let's select all and let's see what happens. So this should now be 91 pretty much, right? And it is size 91. Okay, let's see what happens. Let's see. Two. So this puts size 1. Get matched named function indices for processing size 1. That doesn't make any sense. That doesn't make sense. It should be 91 both sides, right? Well, let's debug this again. And let's see what's going wrong there. So single bundle and select one. Oh, we got an error. Okay, let's see what it is. Instruction size is not 0. Run comparison. Oh. Oh, I see. I see. The problem is that right. Wait. Actually, I don't understand this. It should have disassembled the other side. Right? Why did it not do it? Oof. Because let's fix the other errors first before we look into this. Yeah. So let's first select one of the lower functions, which has no compare. Okay, now Control A. Good. So okay, there we go. Good. So let's step in here. Side 0. So we have 91 selected matched function indices and 91 here. Let's step in this code here. Okay, so we have count 91 and we resize this to 91. Name function indices. So we have 91 index pair 2 side Oh, I see. That's a problem. Let's retry. A simple mistake. Let's try again. All right. Single bundle. We scroll down, we select here, okay. All right, let's Control A and let's go. Okay, 91, yes. Okay, let's see here, and we have 91. Okay, this looks correct. And here as well, 91, yes. Okay, good. Then next we go in here and there will be 1, 2, okay. 2. Shared work count. 2. 1 strong ref. Yes. Okay. And revision descriptor, command. Command. Chain to last. Okay, let's put a breakpoint in here. Yeah. Breakpoint. Okay, so shared work. So we have number is 2. So it should now skip over to this one here, essentially. And it does. Yeah, okay. And then we should get another hit there. No? Let's take this away. Okay, now we got another, and now it should go in here, and it does. Okay, great. So now all 91 functions on both sides should be disassembled and everything. Let's see. So, and then now we create a new command. And we can also create put a breakpoint in here. And that hits, and we got no assert this time because we fixed the bug. And put this, and we're done. Okay. Well, I hope that this was fast and correct. Let's see what happens if I press here. Control A. Huh. I wonder, like, do we build matched functions? Right, so here, load build named function. Build source lines. Disassemble. Okay, let's see if we get any like loading if when we click stuff here. Well, we do. Like very short. Can we maybe remove all the breakpoints? Okay, now I'm curious how fast this stuff really is. Let's see. So we select single bundle or... Oh, that is fairly fast. What about this one? Seems to be stuck. Yeah. No, it's done. Okay, that actually took really long. The disassemble of all the functions. Yeah. Yeah. So I guess it's good that we have a solution for loading on demand, because if there really is a lot, if there are a lot of functions, it will take a while, right? So I guess in that regard, it's good that that it's fast. Yeah. Okay, good. Yeah. Yeah. Then my expectation is also now, let's close this once more and then open it again. So my expectation is if we drag a selection box over the functions, it keeps loading as we select more and more functions. Let's see. Yeah, see? So it loads one by one as we select the stuff here. There we go. I mean, the visualization is a bit wild, but it works as expected. Yeah. Yeah, if you select a bit faster, then it loads a bit more. Yeah. Yeah. Okay, I think this is correct. It looks a bit wild, obviously. But it is technically, it does what we told it to do. As you can see, it creates a lot of commands. It's now commands close to 3,000. Yeah, because it creates commands for chunks of functions as we select new ones. Yeah. The UI seems to be pretty fast. And the async commands are also fast if we just select like a chunk. Like let's say we select like a couple. Yeah. I think that is decently fast. Yeah. I think speed is pretty good, even with just one thread. It's pretty good. No, I think it only gets faster the more if we add a thread pool down the line. But yeah, I expect that once we have that, there will be some issues revealed, multi-threading issues. So yeah, that needs to be carefully tested. Yeah. Okay, but it seems to work for the most part. Yeah. Okay, that's good. And we get no errors. Let's do Control A once more. It's kind of weird now that it says like the big number on the left side. That was weird. Okay. I think we can take a break now. In the next session, we can probably clean up and submit what we have because it seems to be functional in principle. And then we need to polish the file content storage and see if we find anything else wrong. Yeah. But I think it's already good. It looks very promising. Yeah. All right. Now I'll take a break here and I wish you a great day or night. Until next time. Goodbye.